So let me first thank Chairman Ma. He invited me here to introduce some nano-function materials and its industrial applications. So my name is Weijia, from physics department, but basically in our department, all professors are doing some fundamental research. But however, some of them still carry out for some applications like materials. So let me first, topic actually is introduce advanced function materials and its applications. So in this talk, I'm introduced to 3 types of materials, but all these materials are based on the nanoparticles. So first one, I'm introduced the electro-rheological fluid. So we call it ER fluid, so which is a very famous fluid in our university. The next one, I'm introduced to the smart polymers, so which can be used in some smart window, smart roof, and smart display. The next one is a smart drug, so which is very useful for cancer treatment, or drug delivery. We call it smart drug delivery. So let me first introduce what's a ER fluid. So actually it's a basic fluid. So you can say there's some nanoparticles. So this nanoparticle, just like a powder, it just mixed with liquid. So what's liquid? This liquid is a non-conducting liquid. So it's mixing together. It's like a yogurt, like a yogurt. It's a very, very low viscosity. But however, this material is very, very smart. When this material is applied to the electric field, that means you apply the voltage. It's changing from liquid state to a solid. So this change can be reversible. So we call it a smart materials. Also, we call it solid-like materials. It's not real solid material. It's a solid-like. So this transition is very fast. Its response time is 1 millisecond. So very, very fast. So it's reversible. So here is a conventional ER fluid. So here's a particle. So you just fabricate the nanoparticles like a powder, and then mix with silicon oil. Then silicon oil, any oil is a non-conducting. So you just mix together and then mix and just mirroring. So you can like this. So this is a ER fluid. So this ER fluid is like a yogurt, like a milk. It's a very viscous, very low viscosity. So how to calculate ER strength or ER effect? That means it's the hardness of these materials. So let me show you here how to measure it. So here is a sandwich. The ER fluid is sandwich between 2 discs. So you just pull this upper disc. So you can say the ER fluid can be broken. So we can measure this broken property of the materials and know its Young's modules or hardness of these materials. So you can see here, without application of electric field, that means no field, no voltage applied. So you can say its appearance like an oil. Its viscosity very low, like a water. But however, if apply a little bit electric field, that means 1 kilovolt per millimeter. Like you can use a transformer, and you can use a battery, like this battery, and you can transform to a high voltage. But no current, remember, no current. So you can say it's become doufu. So his hardness become doufu. But however, if you further increase electric field, it's become hard form. And you even very high electric field, his hardness looks like a plastic. So this transition very fast. Just apply electric field. This change from liquid to solid is very, very fast. So what's the application for these materials? So you can think about these materials applications. So how does it work? Actually, it's very simple. It's a principle is very simple. But from 1995, our university started to this investment of these materials. So almost 20 years. How does it work? So this working principle is very simple. You can see here, there are 2 particles just suspend in oil and apply electric field. So this particle will be polarized. Polarized means here's the positive and negative charge goes to the 2n. And here you can say positive and negative can be attractive, like a magnet. N and S attract each other. So this attraction force is proportional to applied initial field. That means it applied to the initial voltage. So you can change the voltage, you can change the force between the particles. Okay, so how about this? So all the particles suspended in the oil, it's just randomly. But however, apply initial field. So all these particles will align along the electric field directions. So this is electric directions. That means it's here, tail, here, tail, connection. So this is a chain. So this is a chain. We call it chain formation of the particles. That means it has some structure change of the materials. Okay, so all these chains surround in the liquid. What's going on for this? So if we further increase electric field, that means you apply high voltage, right? These chains aggregate to form